Hi everyone, let me first introduce myself to all of you. This is Ashnat Kudhari here. I'm a teacher, an actuarial science educator, and a minimalist. Now, in this video, we shall be discussing the indicative solutions for CS1 A, which came in IFoA April 2022 session. Please do note that these are the indicative solutions. In case you come across any errors, be it calculation errors or conceptual errors, do let us know through the comments. So for all the viewers of this video, the way you should go ahead with watching this video is once you are done with watching the video, do take a look at the comments section as well. In case we come across any errors reported by students and we find merit in it, we would be posting the rectifications of solutions on in our comments section as well. Now, before proceeding further with the discussion, let me also inform all of you that we would be starting with our new batches from May 8. This is relevant for IEI July 2022 session, IEI December 2022 session, and IFoA September 2022 session. Classes would be available in live online format, that is students from all across the country as well as world can attend these. The primary mode of communication in these classes, or the primary mode of language rather I should say, is going to be English itself. So even students who are non-Hindi speaking can easily attend these. Students from different parts of the world who know English, can attend our classes. Live offline classes would be conducted in Calcutta. Pre-recorded lectures will also be available. We have already shared the timings of the classes for CM and CS papers, and we would be shortly sharing the timings for the other papers which we teach as well. Do note that over the past 2 years, we had restricted our classes primarily on weekends. So the live online classes were held primarily on weekends only, and the major focus of those were doubt clearing and question solving. But now we are moving back to the way we used to do before COVID, that is conducting a lot of classes, which is reflective by the fact that we intend to cover on average 4 to 5 classes every week throughout the term. So we would be trying to cover, if not all, but a ton of content, be it conceptual lectures, be it question solving, doubt clearing, so on. Do note that we would be having just single live batch for this entire session, be it July, September, or December term. We do not intend to come up with any other new live batches. So in case you're looking forward to appearing exams from any of these sessions and plan to take our classes, specifically the live classes, do join us at the earliest. We have a maximum of uptake for each paper, each session. So beyond that, we do not take further candidates for the live classes, so that we can give our time to our students and ensure that those they do get sufficient time of ours. Pre-recorded lectures would obviously be available later as well. So coming back to the paper, CS1 A April 2022 from IFoA, I have to say that this was a relatively very easy paper compared to last year's and the recent past years, as well as the CT3 papers. So as for the pass marks for CS1, it has varied, given both CS1 A and CS1 B, I expect the pass marks should be, let's say, anywhere between 58 plus minus 2, with a slight tilt towards the upper end only, because I did found the paper relatively straightforward and easy. So let's quickly go through the solutions. Question one, this is basically using the concept of joint distribution, or the conditional distribution, I should say. So the first part, expectation y is coming out to be 86 and variance y is coming out to be 259. Next, question two, we basically have a Poisson process. Do remember that in a Poisson process, the number of let's say claims, or the number of events in a particular time interval, let's say A comma B, is independent of whatever has happened before A. So that is something which we would be using in parts 2 as well as 3 and 4 as well for our comments. So in question two, this is one way of writing. There could be several other ways as well. So any correct way would be marked accordingly by the examiner. So do keep in mind that this is not the only correct representation. Other representations could also be there. So N1 follows Poisson 2. Then we are basically looking for that the number of claims in the second year should be greater than 2. So probability N2 minus N1 greater than 2, given that 5 claims had come in the first year. Now N2 minus N1 is independent of N1, and I have denoted N2 minus N1 as Y, and then Y follows obviously Poisson 2 itself. So probability Y greater than 2 is nothing but 1 minus probability Y less than equal to 2. Y less than equal to 2 is basically Y taking the values 0, 1 and 2, the probabilities of which are here, and the answer is coming out to be 0.32332. Similarly, in part 3, the only difference is if they are mentioning that 0 claims had come in the first year. Again, that should make no difference to our answer, given that N2 minus N1 is independent of N1, and the answer remains the same. In part 4, we just need to comment the same thing only. Claims arriving in second year is independent of claims arriving in first year, and so the probability is same in parts 2 and 3. Irrespective of whatever has happened in the first year, that is not going to influence to the events occurring in the second year. So this was question 2. Then part 5 and part 6. Part 5, now remember that time to the first claim or time between any consecutive claims follows exponential distribution. Therefore, time to the nth claim will basically follow a gamma distribution with parameters n comma 2. Note that I have taken the value of m as 2 over here only, as given in the question. So, and I have defined all those, the notations as well. As for part 6, we basically need to simulate a number, and the answer which I'm getting is 0.11220. Note that some of you could have also used that, u is equal to 1 minus fx. That is another alternative way usually, but we would prefer to stick to this method as well. So even for those who might have used the formula of u equal to 1 minus fx, the examiner could award full marks for those as well. Next, moving forward to third question. So it has almost become, let's say, regularity of a joint distribution question coming in. I would say pretty scoring over here. And it's a very straightforward, very easy, I would say, joint distribution function. 6e to the power minus 2x plus 3y when x and y are greater than equal to 0. So quickly looking at the solution for same. Just a second. This is H2. So we get the marginal distribution of x as 2e to the power minus 2x. So it's option 1. Similarly, we get for y as 3 to the power minus 3y. So it becomes option C. Yes, they are independent because the product of marginal is giving us the joint distribution itself. Then in part 4, we know that y and x are independent. Therefore, expectation y given x greater than 2 is nothing but expectation y only, which comes out to be 1 by 3. Then we are looking for probability x greater than y. So here to get this, we need to basically condition it upon, we need to take a particular value of y and then go about integration. So this is equivalent to saying that probability x is greater than small y, given that capital Y takes the value small y into the PDF. And then we go about performing the integration, and on solving, the answer which we get is 3 by 5, which basically corresponds to option D over here. Again, do note that you're not expected to show the workings for all these MCQ questions. I have mentioned it for completeness of solution. Next, question number 4, part 1. This is direct bookwork. Part 2, identify a suitable population. So this is going to be Bernoulli. So X follows Bernoulli P, where P is the proportion of voters that support party. And in part B, we are basically adding up summation. So do remember that addition of independent and identical Bernoulli results into a binomial variable. So we have binomial 50 comma P over here. Then next, moving forward to question number 5. The definitions are there here. Explain why the distribution of y is Bernoulli. So for a Bernoulli distribution, the y random variable should either take the value 0 or 1, which is the case over here. And the probability of it taking 1 is nothing but probability of xi being greater than 0. And that probability will come out to be 1 minus e to the power minus m. Then in part 2, this is basically likelihood. Therefore, it's option C. And part 3, basically solving, we get that m hat is nothing but minus ln of 1 minus y bar. And in part 4, do remember that for this particular point to be maximum, or should I say minimum rather, uh, just a second, we are looking here for what? State the condition for m to maximize the likelihood function. So this case, sorry, it's written as greater than 0. So what we are basically looking for, it should be basically negative over here. The second likelihood should be negative. That will correspond to basically the first derivative equating to 0 as the point of maximum over here. Yes, so there's basically a negative sign missing over here. So just keep that in mind, and this would be actually less than 0 for all possible values of m over here itself. Next, moving to question 6. Again, part 1, 2, 3, 4. Note that this is nothing but an example of a truncated Pareto distribution. Okay. So this is my likelihood coming out. Log likelihood comes out to be this. Therefore, it's option D. Then in part 2, I basically differentiate with respect to alpha to get this particular point. And then uh, just a second, derive the MLE. So I guess that is something which is in an earlier page. So you basically equate this to 0, and you'll be getting the value of A as n divided by summation log xi minus n log b. Part 3 is comment on the behavior of PDF when beta increases. So a lot of you might think that if beta increases, on the face of it, it looks like the PDF is increasing, but you need to also realize that X is dependent on beta over here. So as the value of beta increases, the corresponding value which X can take shall also increase. So although the numerator is increasing, the denominator is also increasing as well. So what actually happens is that as the value of beta increases, my PDF starts from the right itself, because the PDF is valid over here when X is greater than equal to beta. So my PDF, I could say it to be shifting towards right side. So possible values which X can take increases and PDF shifts towards the right. Now beta hat is going to be nothing but minimum of Xi, whatever sample is there, because beta X, all of the X should be greater than beta, or I should say that beta should be less than all the values of X, which basically implies that it should be equal to the minimum value of Xi. Now I have basically taken y as ln xi. One could take the help of Excel or R programming for calculation purpose. I have basically used Excel, wherein I fed the values of xi, took the logarithm of it, and then using the average function as well as the standard deviation function, I have calculated these values. Again, depending, these are probably exact answers. In case you have found out the individual values of yi and rounded off to, let's say, 2 decimal places, 1 decimal place, integer, or 3 decimal places, your final answer could vary. These are exact values coming in right from Excel. Do note that even in case you have rounded off to 2 or 3 decimal places, most probably you would be scoring full marks. As for the last part, beta hat is coming out to be 5000 and alpha hat is coming out to be 1.009145. Next, which we have is question 7, which basically corresponds to generalized linear model. So expectation X, do remember it's B dash theta, variance X is A theta, A phi into B double dash theta. So we find B dash theta, B double dash theta, and A phi, and then we basically see that expectation X is coming out to be mu, variance X is coming out to be sigma square. Second part is why maybe we should be using a gamma distribution instead of a normal distribution. So the two fundamental reasons is that we generally assume claim amounts to be positive in nature. So a normal is not appropriate since it allows negative values as well. Also, normal distribution is symmetric, whereas generally we might think the claim amounts to be positively skewed. That is, a large number of claims of a smaller amount and few big, few claims of large values. So gamma is positively skewed, so we would want to use that. In part 3, explain using the model output shown above whether the variable opt is significant or not. we would be seeing that it is significant, right? So again, for that you could find the test statistic and correspondingly the p-value and comment on it. Then finally, part 4 is explain the difference between the variable opt and legal representation. So opt is basically a nothing but a variable, whereas legal representation is a factor. So opt can take numerical values between 0 to infinite in this question, whereas legal representation cannot take any numerical value as such. It's a categorical thing. So that is what we need to mention over here. And then finally, model 5, determine which model provides the better fit. So clearly we see that the second model is providing a better fit because the probability value is extremely small. So even at 5% significance, by default we tend to use 95% confidence interval or 5% level of significance. So we would be rejecting H naught and basically concluding that model 2 is statistically better than model 1. So then this is it. Then moving forward to question number 8. This is basically from Bayesian statistics. So question number 8, my option 1 is coming out to be A. Option 2, I have shown that yes, it is gamma with parameters as stated in question. In 3, we know that under quadratic laws, it's basically the mean of posterior distribution. Now do note that here itself, in the question they state, derive in terms of alpha and beta or A or beta. You might think, what about summation Ti? That is also there. So from the next part, we would see that, this should actually be 60, which is not mentioned in the question. It has been missed. So I have already written over here information regarding 60 is missing in question. We got this from part 5 options. So we will just see that. So the question should have stated that a total of 20 data was observed. Or let me just read out from here. Assume that a total of 20 lorries have arrived at the checkpoint, and the total, let's say, waiting time over here has been 60 minutes. That should have been mentioned in the question. So I have made that adjustment in part 3 itself, because it's mentioned that determine the Bayesian estimate for lambda in terms of the parameters alpha and beta. So we would expect all other things to be let's say known numerical values itself coming in the expression. Next is finding the Bayesian estimator for lambda under all or nothing loss. Explain how. So you could explain the method. It finally comes out to be mode. Now how to get the mode? You can differentiate the PDF, then get the point at which it takes the maximum value. Alternatively, at times, it becomes easier to take the log of PDF first and then you differentiate it and basically find the point at which that is being maximized, and that point will be basically corresponding to the mode of the distribution. So this is what you could go about the explanation as well. Now in part 5, identify which one of the following option gives the correct Bayesian estimate for lambda under all or nothing loss. So from here only you will see that in all the options there's a 60 in the denominator, which basically implies that this summation Ti is taken to be 60 over here. And this is the result which I'm using while expressing my answer in part 3 as well. Comment on the difference between the two estimators. So we are using a gamma distribution. It's positively skewed. For a positively skewed distribution, the mean is greater than mode, and that is also something which we are observing here as well. So mean is coming out to be 20 plus 8 divided by 60 plus beta, whereas the mode is coming out to be 19 plus 8 divided by 60 plus beta. So that is one commentary which you could make. Moving forward to question 9, it's almost all the questions are direct comments or direct bookworks. I could just maybe go to option question 5, part 5. Determine the optimal set of explanatory variables. So here we would be looking at the one which maximizes the adjusted R square, which is basically this model, x1 plus x4 plus x3. So that is going to be there. Finally, moving towards the last question. Question number 10, we have been given over here. Summary statistics comment on the relationship between the two variables. So there seems to be a negative correlation from the graph itself. Determine the equation of simple regression line. So we'll take a look at all these 5 parts over here. So part 1, there seems to be negative correlation. Part 2, I'm using page 24 of actuarial tables. Just giving up the final answer, 13.26190 minus 0.001118. Just keep in mind whenever you quote the answer, do maintain some sort of consistency with the number of decimal places you are using. So a lot of you might think, why I have written a zero over here, I could ignore that, but that is due to the fact that I'm willing to use still 5 decimal places. So that's why this zero has been quoted. Part 3 is here. Then we have made the table as well, and we are basically rejecting h naught. And part 5 we are testing. Sorry, we're calculating the value of r, and so in part 4 and in part 5 we're basically testing whether rho is equal to 0.8 or not. Again, we're using the Fisher-Z transformation formula, which is has been given there in the actuarial tables. And we have insufficient evidence to reject H naught. So this was regarding CS1A. Hope you all found this video useful. We would be shortly releasing the indicative solutions for CS1B as well. Don't forget to subscribe to our YouTube channel so that whenever we release any new content, you are notified regarding that. And do like this video if you found it useful and share it with your peers as well. Thank you.